Hello all, welcome to Indian School of Ethical Hacking live workshop sessions. Today we will be looking towards how to configure a simple VLAN, that is virtual local area network, using a tool called Cisco Packet Tracer. Now I will be starting from the scratch, of course, so that everyone can understand, because some of you guys would be new here, right? And one more thing, if you guys miss anything that I have already shown in this session, don't worry, it will be later on available for you to view again, right? Okay, all right, so let's start. First of all, let us try to understand what are switches. Okay, now we are not talking about the switches that we start to start our fan, right? So these are your network devices. Now we are basically talking about Cisco switches, right? Now what are these Cisco switches and how do they look like? Okay, so let me just show you guys. So this is how a Cisco switch looks like. Okay, now this is a networking device. Basically a switch is a network device which is used to connect devices on a computer network by using what we call as packet switching to receive and forward data to the destination device. Okay, now a network switch, which is this thing, is basically a multi-port network bridge that uses MAC address. Now MAC addresses to communicate between the devices. Now what is MAC address? MAC address is nothing but media access control address. Now this is unique for each device to be more specifically speaking, MAC addresses are unique to each and every network interface card that we call as NICs. Now what are network interface cards? Now these are those interfaces through which we communicate using the internet or the network. Now how to see MAC addresses? So if I go to my command prompt and if I click on ipconfig/all and then hit enter, so here I can see my private IP address, my subnet mask, right? And here I can see the MAC address of my network interface card. Now this MAC address is of 48-bit size. This is unique so that each and every network interface card will have a different MAC address. Now this MAC address is provided by the manufacturer or your card vendor, right? Now this is unique. Now switches use these MAC addresses to communicate between devices. Okay, now how they do that? Cisco switches, they basically maintain a table called MAC table. Now this MAC table is nothing but a table which has which MAC address is connected with which port number. Okay, now let me show you. I guess I have a picture of that as well. Okay, so this is what a MAC address table looks like. So we have the MAC addresses of different devices over here, and here we have the port number on which they are connected, right? Now these port numbers basically signifies these ports, these port numbers. Now we will see this thing in a bit once we go to the practical part. Okay, so basically what we understand from here is switches basically communicate using MAC addresses. Fine. Okay, now to show this in practicality, now we will be using a software called Cisco Packet Tracer. Now Cisco Packet Tracer is basically a cross platform visual simulation tool designed by Cisco systems that allows user to create network topologies and imitate modern computer networks. Now this software allows user to stimulate the configuration of Cisco router and switches using a simulated command line interface. Okay, so how can we download this and how can we use this? Let us see that first. Okay, so you can just go to your browser and just search for Cisco packet tracer. Okay, just go to the first link over here, that is netacard.com. Now you'll be greeted with this kind of a page. Now what you need to do to download Cisco Packet Tracer is that you need to enroll for this Introduction to Packet Tracer course. Don't worry, you don't need to take this course. It is absolutely free. No money is no money is to be provided here, right? So now what we need to do here is we need to sign up. Now you can sign up and you can actually go through the course that is 10 hours long, or you can just avoid it, does not matter. Okay, just go to sign up, click on English. Now this is the enrollment form. Just go ahead and enter your credentials. I will just enter mine, and you can actually give a valid email ID. Okay, and then you can just answer this question, and please you can just mark them whatever you want and then submit it. Okay, so your account is being created, has been created. Now what we need to do, we need to fill up these things, and you can just click on register to register it. So we'll just give here our credentials. Keep this company to self, that is fine, absolutely. Create a password. Now keep this thing in mind, you are going to use this same credential to log into the software later on. All right, okay. So 9 5 we'll just hit no, we'll just click on register. Okay, now you can use your same credentials to log in. Okay, now I guess we will be receiving some kind of a verification code over here in our mail. So there we go, and this is the verification code. We'll just copy this thing and we will paste it over here. Verify. We have copied it correctly, yes. Okay, so email is verified. Okay, now this is another form that you can choose to complete. So you can just click over here. I will just fill this up real quick. So you can you can just select none or whatever you want. You can just give less than 1 year, none, or whatever you wish. State, you can just give whichever state you belong to. Do you have a disability? No. Okay, so birth date, you can just give whatever you want, does not matter actually. So we'll just go to 1995 and 11, and we'll just go ahead and create this account. We don't need to launch this course right away, so I will just cross it out. And from here I will go to resources, and there I can see an option called download packet tracer, right? So I'll click on this, and from here we will go down, and as we can see, The Cisco packet tracer is downloadable for Windows, for Linux system, and also for Mac OS. Right, so you click on the version that you have. So if you have Windows for 64-bit, then you download the 64-bit version, or if you have the 32-bit version of Windows, then you download 32-bit version, right? So yeah, one more thing, how can you check whether your system is your 32-bit or 64-bit? Just go to this PC, right click on it, go to properties, and here you will be able to see what bit your operating system is, whether it is 64-bit or 32-bit, right? Okay, now accordingly you can choose whatever you want. Now my system is 64-bit, so I will just click on this one and I will just save this file, but I have already downloaded it, so I am not going to download it again. So once you have downloaded this, just go to your directory where you have saved it, and this is the software that I have downloaded, Cisco Packet Tracer, and I will just double click on this to start the installation process. I'll just click on yes, click on accept the agreement, next. You can choose your different location, no problem. Next, next, hit next again and install. Just next, install, that's it. It's so easy. Okay, so once you have done with the installation, so we will go ahead and launch Cisco Packet Tracer right away. So I'll click on finish. And you will be greeted with this login page. So go ahead and enter the same credential that you gave to register your Cisco Packet Tracer. So I'll just go ahead and give my old registration. And there we go. So I have my Cisco Packet Tracer ready to go, right? Okay, now there are a basic few configuration about Cisco Packet Tracer that I will show as the course progresses. All right, so let's get back to our topic now. So we know what a switch is, right? Now let us see how we can connect multiple devices in the sense multiple laptops, multiple desktops with a switch, and see how the communication works out, right? Okay, so as you can see in below here, there are many devices, right? So these are the routers that you can use later on, and these are the network devices. So if I hover on these routers, as you can see, it is showing me routers. Let me just magnify this a bit so that you guys can see. Okay, so as we have here is routers, we have switches, okay, we have hubs, we have wireless devices, we have security, we have WAN emulations, right? So these are all the network devices that you can use to configure your network or to emulate a network configuration that you want to build up later on, right? So these are the routers. If I click on routers, these are all the routers that are available for you to use in Cisco Packet Tracer, right? Okay, so we will head towards switch. So these are all the switches that you can use. Okay, you can just pick any switch. My recommendation for this course will be that you select the last one, the latest one, right? So what I will do, so I will just select this switch and drag it and drop it here. All you have to do is drag and drop, that's it. Very easy, right? So there you go. So I will just drag and drop it. Okay, so this is the switch. Now if I hover over this, as you can see, fast Ethernet 0x1, fast Ethernet 0x2, fast Ethernet 0x3. These are nothing but different port numbers of the switch. Likewise, we have seen in this case, as we see, there are numerous ports over here. Similarly, in Cisco Packet Tracer, you have them as well. So if I just hover over here, fast Ethernet 0x1, so you can compare this with the first port. Fast Ethernet 0x2, you can compare this with the second ports, right? And if you notice carefully, all the ports have different MAC addresses, right? All the ports have different MAC addresses. That means what? If someone asks you hey, how many MAC addresses that does this device has? Okay, or any device, right? So what will be your perfect answer? Your perfect answer should be, it depends upon the number of network interfaces it has, right? The number of MAC addresses that a particular device has completely depends upon the number of network interfaces that device has. Okay, if the device has one network interface, that is through only one interface it can communicate. Now let us just okay, let us just consider our laptop, right? Now our laptop can communicate in three ways. First, through Ethernet cable, right? The Ethernet jack that we use to plug in into our routers or into our device to get a to get a connection. The other thing is through Wi-Fi, right? And the third thing is through Bluetooth. Yes, you don't use internet in Bluetooth, but you can transfer files using Bluetooth, right? Wirelessly. So these three are your interfaces. Now these three will have separate MAC addresses. So in your laptop you actually have three different MAC addresses. Okay, all right. Now one more thing, the Ethernet jack that I was talking about is actually called Cat5 cable. Okay, now let me just show you the image also. I have that image. So this is your normal Ethernet jack. Ethernet jack means this is the wire that is being provided by your ISP to your router. Okay, this is the wire that has been put inside in your system, in your router or in your PC through via the ISP, right? Now this plastic looking jacks are actually called RJ45 jacks, RJ45 jacks, and these cables are actually called Cat5 cable, category 5 cable. Now these cable actually have 8 small copper wires in them, as you can see here. 1 2 3 4 5 6 7 8. Now let me zoom this a bit so that you can understand this more clearly. Now if you look closely, there are 8 wires, 1 2 3 4 5 6 7 8, right? So 8 copper wires combined together will form one Cat5 cable. Now this cable will be used to communicate between the switch and the device. All right, so we will be using this switch. Now we will be using this cable, sorry. Okay, now in Cisco packet tracer, all the cables are available below. All the cables are available below. So let me just, okay, before showing the cables, let me just go to the devices. So I will just click on end devices, and here I can see so many end devices, right? PC, laptop, server, right? Okay, so we will take, say, I will just take 4 laptops. Oh, I'm really rich. I am just taking 4 laptops right away. Okay. All right, so now what we are going to do, we are just going to connect all this end devices with this switch, right? Now we will be using the same Ethernet cable, right? Now that is what we call as a straight through copper wire. Now how can we get this wire? Just go down below and click on this connections. Now in this connection you will find one black straight line. If you hover over this, you will see copper straight through is written over here. Okay, let me just magnify this again so that you guys can see. Okay, so this is the connections, and we will straight away go to this part, that is the straight copper wire, right? So as you can see below, it is written straight copper through wire, so straight copper straight through wire. We'll just select this one. Okay, I will just cut this, minimize now, and we'll just click on this switch, and we will select the fast Ethernet jack. We will join this and we will drag it and click on the laptop, and we will connect it using fast Ethernet again. Okay, so there you go, we have connected the first laptop to the switch, right? We'll do this for the next 3. Okay, now we have connected all the devices to the switch, right? Now if I go to this PC, if I click on this PC, we can actually configure the IP addresses of this PC, right? We can configure the IP address of this PC. So we'll go to desktop and we will go to IP configuration. Now what we are going to do, we are going to keep all these PCs in the same network. We are going to keep all this PC in the same network. So I will just give the static IP address over here, 192.168. Say you can just give whatever you want, 192 168.0.23. You can just give whatever you want. You give the subnet mask, and we won't be giving any kind of a default gateway as we don't have any router over here. We will just head to the next one, do the same thing for the second one as well. 192.168.0.31. You can just give anything. Just keep in mind they should be in the same network. How can you ensure that? Just keep this part same, 192.168.0. that's it. Go to this part, desktop, IP configuration, and here I will just give the IP address. You can give whatever you want. Okay, right, so we have provided the IP address to all the devices, right? Okay, now since all the devices are connected in the same network, now we will try to send some kind of a packet so that we can see whether we are able to communicate with the other PCs or not, right? So what we are going to do, from one PC to the other PC, we are just going to ping. Okay, let me just do one thing. I will just go to preference and I will increase the font. You can also increase the font like this. Just go to fonts and increase it to say 17. Just apply this. Alright, so we'll go to the PC, go to the command prompt, and here what we are going to do, we are just going to ping the other PC, ping 192.168.0.33. okay, so as we can see, we are getting the reply back, right? So basically one PC is able to communicate with the other. Now there is another way to check this communication. You just pull this thing off. You can, as you can see, this is there is a small arrow sign over here. Let me just magnify this part. Okay, as you can see, we have an arrow. Let me just magnify this a bit more. As you can see, yeah, so as you can see, there is a small arrow thing over here. You just click on this arrow part and it will give you another drop down, right? So now what we are going to do, we are just going to send some kind of a packet from this PC, say, to this PC, right? So we'll just click on this packet, click over here and send to this PC. So as you can see, it is stating me that the packet sending is successful. That means what? This PC can communicate with this PC easily. So basically what I am trying to say is, within a switch, if you keep all the devices in the same network, they will be able to communicate with each other, right? So this is a good thing in one way, but in another way it can prove disadvantageous. How? Now let us just consider a situation. Let me just explain this using paint. Now let us just consider a situation where you have a building or a company. Say for example, you have a company and it is in a building which has, say, 3 floors, right? So I will just give here 3 floors. Pardon my drawing, I'm not that good in drawing. Okay, so there you go. So we have 3 floors, right? And in these floors we have different computers, right? Let us just consider we have one red computer, a green one. Okay, it's turned green anyway. Okay, so yeah, I'll just keep it that red. And another one, we can just say that, okay, let's just keep another one red. So we have another red. Now let us just keep this one as blue. And we have another PC. Let us just keep this as green. Okay, now let us just consider a situation like this, where we have the green PCs, we have the blue PCs, and we have the red PCs, right? Now let us just consider that these green PCs actually belong to accounts department, right? Now green PC belongs to, say, accounts department. We'll just write A over here, belongs to accounts department. Okay, now the blue PCs belongs to, say, management. Okay, and the red PCs say belongs to sales department, right? So we have a situation like this. So we have accounts department PCs, we have management department PC, and we have the sales department PCs, right? Now if we consider a situation where the all of them are in the same network, then what will be the actual situation here? That means what? They are connected with the same switch. They are connected with the same switch. So let us just connect them with the same switch. So let us just consider this to be like this. So they are all connected using the same switch. Okay, they are all connected using the same switch, right? So basically they are in the same network. Now the problem here is, since they are in the same network, each and every one of these PCs can actually see all the other PCs traffic, right? All the other PCs traffic. So basically the one in the accounts department can also see what packets are being sent from the management to the switch, right? So basically anyone can actually capture these packages and can leak confidential information, right? So this is giving me a security issue over here. Since all of them in the same network, there is no other way to segregate them, right? If there was a router, then definitely we would have, but in this situation we cannot. Then how can we overcome this situation? This is where your VLAN comes. Okay, so what is a VLAN? VLAN is actually virtual local area network. Okay, virtual local area network. So in a VLAN, the computers, servers, be it any other network devices, are logically connected regardless of their physical condition, right? So even if these devices are scattered at different places, it wouldn't matter, because a VLAN can logically group them in separate virtual networks, and that is why the VLAN is used. So the main purpose of VLAN is to improve security, improve traffic management, and make a network much more simpler. So instead of using a scenario like this, if I had used a VLAN, how it would have looked? So let me just erase all these cables from here, right? So let us just consider the green ones are having a single VLAN for themselves, right? The red ones are having a single VLANs for themselves, and the blue ones are having a single VLAN for themselves. So in this scenario, only the devices within the same VLAN can communicate with each other. You get my point? So basically the devices in the same network and in the same VLAN can communicate with each other. VLANs cannot communicate with each other. Get my point? So basically green VLAN cannot communicate with the VLAN blue. Red VLAN cannot communicate with VLAN blue, and vice versa. So like this, we can segregate the devices in the same network and group them together so that only they can communicate between them. Right, now let us see this in practical. Okay, all right, so I will just use this same scenario over here and show you what kind of a effect can we have if we don't have a particular VLAN. Say for example, these are my, let me take multiple devices over here. So I will just take 3 laptops per VLAN. So let us just take this one. It will be for my say accounts. Okay, and this will be for the sales, and this will be for the management. Okay, now let us just consider management has a server, right? Okay, in which we have confidential data stored. Okay, so let us just connect them. All right, so we have connected them all together. Okay, so we can also give some kind of a color so that you can understand pretty well that which device belongs to which VLAN. So I will just put a color over here. So let us just consider the red ones to be the okay, let me just give here red one, and we have the green one, and we have the blue one. Okay, and let me just state this is my sales department, right? This is my accounts department, and this is my management, right? Okay, so now what we do, we will just give IP addresses to the devices. Let me just check whether they have the IP addresses or not. Okay, so I will just give the IP addresses 192.168.0.21. Just keep them in the same network. We'll keep them in the same network. Okay, so this has the IP address, and this also have the IP address. Okay, all right, 192.168.0 dot say 49. 192.168.0.57. You can give anything you want as long as it is in the same network. 68.0.101. And we have the server IP address as 192.168.0.100. We'll just keep this simple so that I can communicate with the server easily. Okay, so basically our network diagram is ready. Now let us see what is the problem over here. The problem in this scenario is we have a server in the management department, right? And we have the sales department and the accounts department. Now if I try to communicate with the server, if I try to ping the server, if I try to communicate with the server which has confidential data in it, I will be easily be able to do it. So if I try to send some kind of a packet over here, so as you can see it is successful, right? Now if I do the reverse one, say the server is sending some kind of a data to the PC, it is also successful. That means what? Any device from the sales department or the accounts department can communicate with the confidential server, right? Similarly, the sales department can easily communicate with the accounts department. Management can communicate with the accounts department. All the data in the accounts department is shareable to all of them, right? Now if you don't want this kind of situation in your industrial network, then what we need to configure, this is where the VLAN comes. You need to configure simple VLAN, right? Now let us just see how you can do that. So this is the switch that we can configure to create multiple VLANs. So how will I configure the switch? In Cisco Packet Tracer, we will just click on this. Then we will go to CLI, that is the command line interface, right? Now this is as easy as it is. We can directly click and go to the CLI, but in real life, obviously if you click on these switches, you won't get anything, right? So in real life what happens, we basically connect this switch with a laptop, right, using what we call as a console cable. Now a console cable looks exactly like this. So we have RJ45 jack in one side and VGA jack on the other side, right? This VGA jack will get connected with the laptop with which you are trying to configure the switch, and this RJ45 jack will get connected with the console port of the switch, right? Okay, so in Cisco Packet Tracer we have the console cable right over here. If you see this kind of an arc blue colored wire, this is what a console cable is. Just click on this, we'll connect it to RS232, that is the VGA connection, and we will connect it with the switch through the console jack. Okay, and there you go. Right, now how to open it? So we will just go to the laptop, we'll go to desktop, and in terminal we will hit OK, and here we are greeted with the terminal interface of the switch. We are given the terminal interface of the switch. Okay, so I will just hit enter. So as you can see, this is the user prompt that we get upon getting inside the CLI of the switch. This is the user prompt, right? Now there are different modes of communicating with the switch. This is the normal one. There is another called enable mode, and there is another mode called configuration terminal mode. Now you have different sets of command for each mode. So for the sake of this video, we are going to go do VLAN configuration. We will be sticking with configuration terminal mode, right? So how we will get into it? We will just give the command enable, and then we will hit enter. So as you can see, the prompt has changed a bit. It has turned to hash now, and then we will give the command config space t, which is actually configuration terminal. You can write the whole thing configuration. You can either write the whole thing configuration terminal, or you can just write config t. Both will work. Config t. Okay. So basically this is the configuration mode. Now in here what we can do, we can actually configure all the switches that we can, all the switch which we are trying to configure over here, right? Okay, fine. Now what we will do, now if you can also see the VLAN information right away in the switch. So if I do show VLAN command, if I give the show VLAN command, sorry, if I just give do show VLAN command, if I give do show VLAN command, if I hit enter, as you can see, there is already one VLAN, that is default VLAN, that is active, and inside all the ports are there. So basically Cisco switches are basically configured in such a way that they already have a default VLAN in them. Cisco switches are set up by default so that every port on the switch are a port of default VLAN, which is VLAN number 1, right? Okay, so that is one of the reason why you can communicate within the switch easily. Now what we are going to do, we are just going to create multiple VLANs, right? We are going to create multiple VLANs. Fine. Now to create VLANs, what we need to do now is, we'll just state the VLAN number first. Say VLAN 2. Since VLAN 1 is already taken by the default VLAN, we cannot use VLAN 1 over here, right? So we will just give VLAN 2. Hit enter. Now you can name this VLAN whatever you want. Say for example, I will just keep the name to be accounts. I will exit from here. I will create another VLAN, VLAN space 3. We'll just give the name as sales. Exit. Right. We will create another VLAN, VLAN 4. We'll just give the name as management, and we will exit. So now if I do show VLAN and hit enter, as you can see, we have created multiple VLANs now. We have accounts department, we have sales department, and we have the management department. All the three VLANs are active. All the three VLANs are active, but you still can communicate with each other. Why? Because the VLANs do not have any ports in them. All the ports are in which VLAN? The default VLAN. Now what you need to do, you need to put each and every port, each ports which belong to that particular department inside their respective VLANs. Okay, in their respective VLANs, correct? Now let us see how you can do that. All right, fine. So these are the ports that we need to, let us just try to first configure the sales department, right? Okay, now you can just hover over here to see which port number is connected with this PC. As I can see, in my case it is F fast Ethernet 0x5. Or you can do another thing, you can just go to you can just go to preferences, option preferences, and you can just select this option, always show port labels in logical workspace, and you will be able to see the numbers, right? You can see the port numbers right over here, right? So we have F0x5 over here, we have F0x2 over here, and I guess we have F0x1 over here, right? F0x1 over here for the cells. Now what we are going to do, we are going to put all these three port numbers of the switch inside the sales VLAN, right? So we have 0x1, 0x2, and 0x5. So how will I do that? So I'll just go to the terminal. Sorry. Okay, so now what we will do, we'll just get inside the interface now. Say interface f0 by 1, right? f0 by 1, and then what we will do, we will give the command switch port mode access. Okay, now you need to change the mode to access. Now what is, now there are some modes in switch. We have access mode, we have trunk mode, we have hybrid mode. Okay, so among this, access mode is a mode basically which allows for the port to become to be able to communicate using only a single VLAN. So an access port can have only one VLAN configured on the interface. It can carry the traffic for only one VLAN. Okay, so if I put it into trunk mode, it will be able to communicate with multiple VLANs, but we don't want that, right? We want it to communicate only with VLAN sales. So that is why we are putting it as access mode. So switch port mode access, hit enter, right? Now what we will do, switch port access VLAN. Now you can just see which VLAN you have created for the sales department. So we have VLAN number 3 for the sales department, right? So we'll just give the number over here, VLAN 3. Okay, same goes for the other one. So we will exit from here, interface f0 by 2. I guess it is f0 by 2. Let me just check it again. Yes, it is f0 by 2. So just f0 by 2, same command, switch port mode access, switch port mode access, and then switch port access VLAN 3, right? Exit, interface f0 by 5. I guess it is 0 by 5. Let me just check it again. Yeah, it is 0 by 5. Same command, switch port access, switch port mode access, switch port access VLAN 3. Okay, exit. Now if I check it again, do show VLAN. If I just try to check the VLAN information in the switch now, if I hit enter, as you can see in the sales department, or in the sales VLAN, we have successfully inserted 3 ports. That is port number 0 by 1, 0 by 2 and 0 by 5. That means what? All the PCs connected to these ports now belong to the sales department. Okay, now we are going to do the same thing for the accounts and management department as well. Okay, so this is like f0 by 6, this is f0 by 4, and this is f0 by 3. So we have 3, 4 and 6. Okay, we have 3, 4 and 6. Now let me show you another technique. Like you can actually do it one by one. You can actually do this configuration by going one interface to another, or you can use another command, that is the interface range. So if I just give here interface range f0 by 3 to 4, since we have 3 and 4 together, so we have here 3, we have here 4. Since we have 3 and 4 together, we can just give it like this, interface range f0 by 3 to 4. If you had more, say for example, if you had like 3 to 15, then you could have given like interface range f0 by 3 hyphen 15. Okay, if you want to put all the if you want to put all the PCs from port 3 to port 15, if all of them, if you want to keep it in the same VLAN, then you could use this command, interface range f0 by 3 hyphen 15. Since I want to put these 2 ports in the same VLAN, I wrote it like this, right? So interface range f0 by 3 hyphen 4, hit enter. Now you give the same command again, switch port mode access, switch port access VLAN. Okay, now this is a different VLAN. So this is let me just check, this is my accounts department, right? So we have the accounts department as which VLAN? We have accounts department as VLAN number 2. So we'll just put it 2 over here. Okay, exit. Now interface f0 by 6, switch port mode access, switch port access VLAN 2, right? So if I do show Vlan now, do show Vlan. Okay, so as you can see, in the accounts department we have successfully added all the ports, if 0 by 3, 0 by 4 and 0 by 6. Now only the management department is left, so we'll just check which are the port numbers for the management department. So we have 0 by 9 over here, we have 0 by 8 over here, and we have 0 by 7 over here, right? So we have 7, 8, 9, right? So continuous, so we will be using interface range in this case. So I will just go to the terminal. So we can use interface range F 0 by 7 to 9. Interface range F 0 by 7 to 9. So that all the three ports get configured all together. So switch port, mode, access, switch port, access, VLAN. Okay, now this VLAN number is VLAN number 4 for the management, right? So we will just hit 4. Now if I exit, you can exit from here. Now if I see do show VLAN, so as we can see the management, in the management VLAN we have F0 by 7, we have F0 by 8, and we have F0 by 9, right? So all of them are in the same VLAN now, right? Okay, so we have now successfully configured this VLAN. Now let's check whether they can communicate with each other or not. Okay, so our VLAN is ready at the moment. Okay, now let's try to check. So if I try to send some kind of an information from this PC to the server, if I try to ping that server, it is failing. So you let me try it again. As you can see, it is failing now. So if I try to communicate between the sales and the accounts department, failed. Okay, accounts department with the management department, failed. The management department with the accounts department, failed, right? But if we communicate between ourselves, say accounts department with the accounts department, it's successful. So between management and management, successful. Between sales and sales, it is successful. But if we try to communicate inter-department, this is where the packet gets dropped. If so, basically, even though all the PCs are in the same network, all the PCs are in the same network, all the devices are in the same network, they are not able to communicate with each other, since I have segregated them and grouped them into different VLANs for security purpose. Previously, this PC was able to easily access the data in the server, right? But now it cannot. Okay, so using simple VLANs, you can create a much more secured network, right? And the second thing is that say for example, in real life, when we generally configure such kind of a VLAN, we generally keep some extra ports for those, for any VLAN, like, right? Say for example, we have 2 more ports for VLAN sales, we have 2 more ports for accounts department, and we have 2 more empty ports for management, right? So in case if any PC is trying to communicate with this server for some specific reason or some emergency purposes, then we can just plug it out and plug it inside the VLAN of management easily. Okay, let me just show you with this with an example. So let me just do one thing. Let me just give another one extra port inside this VLAN management. Say for example, if I just give, okay, so we have up to 9 we have done. So let me just take interface F0 by 10 as one of the extra ports in the management. So interface F0 by 10. Okay, we will just give it at switch port mode access, switch port access VLAN, and this is the management, right? So VLAN number 4, right? Okay, so we have one extra port for your VLAN number 4. So if I do show VLAN, as I can see, F0 by 10 is now belonging to management department, right? Now say for example, if this PC for some kind of a specific reason or for some emergency purpose wants to communicate with the devices in the management, okay, so what we can do, we can just unplug it and plug it back into that particular interface which is inside that VLAN, right? So if I connect it with fast Ethernet 0 by 10, which is inside VLAN number 4, and if we just give it some time and we will check Yes, as you can see, it is successful now, right? Just by changing the ports, you will be able to communicate, right? Now, since once the communication is done, we can just open it up and connect it with the same old sales department. Okay, so this is how you can create a simple VLAN using Cisco Packet Tracer. Okay, fine. Okay, if I check in the real-time simulation, like what is happening in the background, so we'll just hit the real time. Let me just delete this part, and we'll just hit the simulation. So we are trying to send from this part to this accounts department. Okay, so first of all, let me just delete this again. Right, so I will just send it to this PC. Okay, now if I try to send this, if I start sending it, so basically this green packet is the ARP, that is address resolution protocol, that is being sent so as to map the MAC addresses with their IP address to create the MAC table for the first time. So as you can see, the ICMP packets are not even transferred. The ICMP packet is not even transferred, right? We don't see any yellow packets. Okay, because it is trying to communicate from one VLAN to the other, right? But if we try to communicate from within the same VLAN, okay, and if I try to send this packet now, so first of all, it is going to send the ARP requests, and once that is complete, it is going to send the ICMP packet. So there you go, the blue packet, the ICMP. As we can see, the blue packet is going to be the ICMP. Now ICMP is nothing but the normal ping, the ping that we used to do through our terminal or what. So basically ping is ICMP protocol, internet control message protocol. Okay, so basically ping is nothing but, say if you go to CMD, if you want to check if your internet connection is correct or not, say if you want to check whether the website you want to go to is available or not, so we just give ping, say google.com. Okay, and we will get the reply. So this is nothing like, we have done this in real life many times. Say for example, I want to chat with you guys, right, using WhatsApp. Then what will I do? I will just ping you guys, right? Hey, are you online? Right, and you guys will reply me with yes, we are online. That is the same thing that is happening over here. That is what a ping is. So basically I am just trying to see whether that particular device is online or not. Okay, and can receive data packets or not. All right. So this is how you can configure a simple VLAN in Cisco Packet Tracer. I hope you enjoyed this session. I will end my session today here. Okay, if you have any question regarding this, regarding configuring this simple VLAN, or regarding Packet Tracer, or regarding the switches, or anything, whatever I have shown you today, you can just post it in the comment section below. We will try our best to answer each one of them. Okay, thank you all for joining us in this session. Have a nice day.